Glitch in the Matrix, the podcast where we explore the weirdest corners of science and technology. I'm Jenny, and today we're diving into a topic that's sure to blow your mind: how a slime mold algorithm is helping us understand the structure of the entire universe. Joining me are our resident tech enthusiasts, David and Matt. Are you guys ready to get slimy?
Always ready for some slime action, Jenny. This topic combines two of my favorite things: bizarre biological phenomena and cutting-edge cosmology. I'm excited to see where this conversation leads us.
Count me in. I must admit, when I first heard slime mold algorithm, I thought we were discussing some new indie game genre. But modeling the universe, that's on a whole other level.
Right? It's like nature is playing a cosmic game of connect the dots, and we're just figuring out the rules. So let's start with the basics. This algorithm mimics the growth of slime mold, but researchers have adapted it to model the large-scale structure of the universe. David, you're our resident slime mold enthusiast. Can you break this down for us?
Gladly. So, picture this. Slime mold is this fascinating organism that can find optimal paths to food sources by reforming its structure. It's like nature's own problem-solving machine. Now, imagine applying that same principle to the cosmos. The algorithm essentially grows along the paths of least resistance in the universe, much like how slime mold spreads to find nutrients.
Wait, so we're basically treating the entire universe like a giant petri dish? That's both awesome and slightly terrifying.
I know, right? It's like we've stumbled upon some non-human intelligence that's been modeling the cosmos all along. But here's where it gets even cooler. This algorithm is helping us visualize something called the cosmic web. Matt, you're our tech guru. What can you tell us about this cosmic web?
Well, Jenny, the cosmic web is like the internet of the universe, but instead of cat videos, it's connecting galaxies and dark matter. Imagine stretching a giant spider web across the night sky. That's kind of what we're dealing with here. These filaments of galaxies and dark matter stretch across mind-boggling distances, with enormous voids in between.
And this web isn't just a static structure. It's been evolving since the Big Bang, with gravity pulling matter together to form galaxies and clusters, while the universe itself keeps expanding. It's like a cosmic tug-of-war that's been going on for billions of years.
This is blowing my mind already. So we've got this slime mold algorithm modeling this incomprehensibly vast structure. But why is this such a big deal? What are we learning from it?
Well, from what I understand, this new method is giving us a much more detailed look at how matter is distributed in the universe. It's like we've upgraded from a blurry satellite image to a high-def drone shot of the cosmos.
Exactly. And it's not just about pretty pictures. This algorithm is helping us understand how galaxies evolve over time. The team behind this research, led by Farhan Al-Hassan and Professor Joe Burchett, found some really intriguing results.
Oh, do tell.
So, get this. The team discovered that the impact of these cosmic structures on galaxies has actually reversed over time. In the early universe, being close to larger structures stimulated galaxy growth. But in more recent cosmic history, proximity to these structures seems to limit galaxy growth. It's like the popular kids in school suddenly became bad influences.
Hang on, that's fascinating. So, are you saying that in the cosmic high school of the early universe, hanging out with the big galaxy clusters was the cool thing to do, but now it's better to be a loner?
I love that analogy, Matt. But I'm curious, how did they figure this out? And more importantly, why couldn't they see this with previous methods?
Great questions, Jenny. The key here is the level of detail the slime mold algorithm provides. According to Hassan, their method produced far more detailed discrete structures than the old approaches. It's like going from a flip phone camera to the latest smartphone. Suddenly you can see all these details you missed before.
That makes sense. In tech, we often see that a seemingly small improvement in resolution or processing power can lead to major breakthroughs. But I'm still wrapping my head around how a slime mold algorithm can do this. It feels like we're using a biological cheat code to understand physics.
I know, right? It's like the universe is running on some bizarre operating system and slime mold somehow has root access. But let's dig deeper into what this means for our understanding of the universe. How does this change our view of cosmic evolution?
Well, it suggests that the relationship between galaxies and their environment is much more complex and dynamic than we thought. It's not just a simple bigger is better scenario. The cosmic web isn't just a backdrop. It's an active player in how galaxies form and evolve.
So it's like the cosmic web is both the stage and the director of the universal play. That's mind-bending. But here's what I'm wondering. Could we use this algorithm for other aspects of cosmology? Like, could it help us understand dark matter or dark energy?
Ooh, good point, Matt. And while we're at it, what about using it to model other complex systems? If it works for the cosmos, could it work for climate patterns or economic systems?
Those are exciting possibilities. From what I understand, the team is already thinking about using the algorithm to map out gas in the universe across different time periods. It's like we found a new tool in our cosmic toolbox, and we're just starting to explore what it can do.
I can't help but think about the computational power needed for this. Are we talking supercomputers here, or can this run on a decent gaming rig?
Good question, Matt. And it makes me wonder about the future of this research. What's the next step? Are there other unexpected sources of inspiration, like slime mold, that could revolutionize our understanding of the universe?
Well, as the saying goes, life finds a way. Or in this case, life finds a way to model the universe. Who knows? Maybe next we'll be using ant colony algorithms to understand quantum mechanics, or using coral reef growth patterns to model multiverses.
Now that would be a glitch in the matrix. But seriously, this research seems to open up so many possibilities. It's not just about understanding the cosmos. It's about finding new ways to approach complex problems.
Absolutely. And it highlights the importance of interdisciplinary research. Who would have thought that studying slime mold could lead to breakthroughs in cosmology? It makes you wonder what other connections we're missing.
You're absolutely right, Matt. This whole discussion really hammers home the idea that inspiration can come from the most unexpected places. It's a reminder that we shouldn't dismiss any area of study as irrelevant.
Definitely. And it goes beyond just academic curiosity. This kind of cross-pollination of ideas could have real-world applications. Imagine using slime, mold-inspired algorithms to optimize transportation networks or design more efficient computer circuits.
Or even in my field of tech development. We're always looking for more efficient algorithms for data routing and network optimization. If a slime mold can model the cosmic web, maybe it can help us build better internet infrastructure.
That's fascinating. It's like we're learning from nature's own optimization strategies. But let's zoom out for a moment. What do you think this research says about our place in the universe?
Well, for me, it reinforces the idea that we're all connected in ways we're just beginning to understand. The same principles that guide a humble slime mold also shape the largest structures in the universe. It's humbling and awe-inspiring at the same time.
I see it as a reminder of how much we still have to learn. Just when we think we've got the universe figured out, along comes a slime mold to shake things up. It keeps us on our toes as scientists and researchers.
That's a great point, Matt. It's like the universe is constantly challenging us to think outside the box, or outside the petri dish in this case.
Absolutely. And it's not just about the specific findings, but about the approach. This research shows the value of looking at old problems with new eyes. Who knows what other natural processes might hold the key to understanding complex systems?
True. It makes me wonder about other potential applications. Could we use similar algorithms to model climate change, predict economic trends, or even understand human behavior on a large scale?
Those are exciting possibilities, Matt. It seems like we're just scratching the surface of what this approach could do. But as we wrap up, I'm curious, what's the one thing each of you is taking away from this discussion?
For me, it's the reminder that nature is the ultimate problem solver. We've got billions of years of evolutionary optimization all around us. We just need to learn how to tap into that wisdom.
I'm struck by the power of interdisciplinary thinking. This breakthrough happened because someone looked at a cosmology problem and thought, hey, what if we tried this biology thing? We need more of that kind of out-of-the-box thinking in all fields,
Great points, both of you. For me, it's the sense of wonder. Just when I think the universe can't get any more amazing, we discover something like this. It's a reminder of why we do science in the first place, to uncover the awe-inspiring secrets of our reality.
Well said, Jenny. It's been quite a journey from slime mold to the cosmic web. I can't wait to see where this research leads next.
Same here. Who knows? Maybe in our next episode, we'll be discussing how butterfly migration patterns help us understand dark energy.
Now that would be something. And on that note, dear listeners, we've come to the end of another mind-bending episode of Glitch in the Matrix. If you've enjoyed our slime-filled journey through the cosmos, don't forget to like, comment, and subscribe. Your engagement helps us continue bringing you the weirdest and most wonderful discoveries from the world of science and technology.
And if you have any ideas for natural phenomena that could revolutionize scientific understanding, drop them in the comments. Who knows? You might inspire the next big breakthrough.
Or at least the next viral TikTok trend. Explain the universe using household items challenge, anyone?
I'd watch that. Until next time, keep questioning reality and stay curious. This is Jenny, David, and Matt, signing off from the Glitch in the Matrix podcast. Remember, in a universe modeled by slime mold, anything is possible.